Hello everyone, this is Mr. Ege again. This time I'm continuing with the front of the clock project, at the front faceplate of the clock project. And when you were away, I added teeth, 60 digits of a gear on the around the clock, and I can literally, I know you can do it easily by just selecting the back face, the back plane, and create a sketch and add a rectangle, and just simply multiply the rectangle by the copy command using the circular copy command. Okay, and I made 60 copies, and then I extrude each one of them one by one. And you already know those commands, how to do it. Okay, so probably you don't need me to show you at this level. And now I have a structure that looks like a gear, okay, with the 60 teeth all around the clock, okay? This is literally a simple extrusion project after drawing a rectangle and multiplying the rectangle using a circular copy command, okay? Or circular pattern command right over here. And that's why I didn't need to show you, because you can do that much, you know that much a lot. And probably you enjoyed figuring out yourselves too, and if not, raise your hand, I will be right next to you, okay? So at this point, I'm assuming that you are done with the front of the clock. You don't have to do the tooth all around it is not necessary, absolutely. I added for extra design. It's not required, okay? Now I'm showing you the back side of the clock, and the back side of the clock is like that. And the reason we're turning back side of the clock is that we're going to add 6 axles. And those axles are going to enable you to mash multiple gears that's required for the operation of the clock mechanism. So clock is a system, actually, made out of many parts, okay? And mostly it works on gears, multiple gears mashing into a certain order, mathematical and engineering order, such a way that it rotates every minute arm, second arm, hour arms rotate properly, proportionally with each other. In order to get that done, each gear needs to have axle. If you provide the axle, then, and if you know the size of the gear and the mechanical advantage related to number of gears, computer will enable you to, the inventor software will enable you to mash those gears and generate automatically for you. That's one of the strengths of Inventor. Inventor is a very powerful mechanical, in general, engineering program. Air and space engineering, mechanical engineering, automation engineering program. Robotics people are also using, and the NASA people are also using, and inventors. So I turned the back side of the clock, okay, using the orbit command on the side, and now I can get out of the orbit command to show you that. And those axles that I'm going to build, okay, is going to be at the corners of a hexagon. I need 6 axles. Not that I need all of them, all of the 6, but number of different configurations of the 6 axles will enable me to generate those gears properly. So what do I need is a hexagon drawing, okay? The hexagon has 6-sided polygon, okay? And from the edge to edge, corner to corner, 6.5 inches. And to do that, I went to polygon command. I selected polygon at the end of the list. I specified 6 sides, okay? And I picked up the second option, circumscribe polygon. I picked the center point, I picked the top point, okay? And now I'm describing what I did because you are so advanced up to this point that you don't need to see me drawing a hexagon. Obviously you can do it. And then after that, I dimensioned the two left and right corners of the hexagon, 6.5 inches. Okay, so now that hexagon is drawn, at least I need one single circle here to extrude as an axle. I drew the circle command, selected the circle command, I clicked on it at the corner of the hexagon, top left corner, shoulder of the hexagon, and I created a circle and I dimensioned it 0.5 inches. So diameter, and OD, by the way, 0.5 is called OD. OD means outside diameter, okay? So when you're talking about axles, this is going to be a solid axle. But there are a number of other axles are possible. I mean, there are pipe axles, for example, solid axles. And most axles are cylindrical, but some axles are not. So just keep in mind that you're looking for generating 0.5 half-inch thick, okay, cylindrical axle. Now, one circle is done, and I need 5 more. I'm not going to create 5 or copy 5 times. Instead, I'm going to use the circular copy command, okay? I'm going to select by dragging my mouse the circle I like to, and I'm going to move my cursor over the arrow that says center of the circle and click, and then move my cursor to the center of the entire drawing, click, and I need 6 of them, and 6 is already there, and okay it. Now I have 6 circles, okay? Am I done? Almost. I'm almost done with finishing the sketch. I finished the sketch. Now I'm going to extrude those axles. How much do you think I should extrude? I'm going to try 1.5 inches to see how it goes, okay? And I selected the extrude command, okay, and add 1.5, okay? And I'm going to change the angle a little bit so that I can see the extrusion. I have to see the extrusion. Am I moving my cursor over the circle? Click. And the extrusion direction looks right. It's just that 1.5 is not enough. I don't think it's 1.5 is going to be enough. And I'm going to make it 1.5. Maybe we should do more than that. This is not going to be enough, I'm pretty sure. How about 3 inches? That's better, okay? I'm going to go with the 3-inch extrusion just in case. If I need to later on, I can definitely change that number, okay? Okay, so I have now exactly 6 axles, and I'm going to okay this. Okay, that's good enough for me to establish the gears. I think this is looking perfect right now. I'm going to save everything, save as, okay. And please do this part, okay, before you start the next drawing. The next drawing, okay, that we're going to start, this is one part drawing. And I think we are finished with this part drawing. Next drawing is the second part drawing for arm, mechanical arm. We're going to start from the second arm. We're going to continue in other part that is going to be minute arm, then continue in other part that's going to be our arm, and we're going to make them in such a way that their axles will fit in each other, okay? So please pay attention to where you're saving. I'm going to go and file, save as, and I want to just check it out where I'm saying gears of a clock. It's my STEM engineering, okay? And save. Now, next time, okay, I'm going to demonstrate the next level. Thank you.